Welcome to Astronomy Daily, your daily dose of space and astronomy news. I'm your host, Anna, and today as we close out 2024, we've got an exciting lineup of stories from stellar explosions to perfect planetary systems and upcoming cometary visitors. To get us started, let's take a look at the latest stunning image from our most venerable space-based telescope. The Hubble Space Telescope has captured another breathtaking image, this time showcasing the Galaxy Lida 22057, located approximately 650 million light-years away in the constellation Gemini. What makes this observation particularly special is the presence of a spectacular supernova explosion, designated as SN2024 which was first detected in January 2024. In the image, you can spot the supernova as a pale blue dot just below and to the right of the galaxy's core, creating a striking contrast against the galaxy's ethereal spiral arms. This snapshot, taken about 6 weeks after its initial discovery, shows the supernova significantly dimmer than at its peak brightness. What's fascinating about SN2024 is that it's classified as a Type Ia supernova, which occurs through a remarkable process involving a white dwarf star. These white dwarfs are essentially the crystallized cores of stars that were originally less massive than 8 times our Sun. They're incredibly dense objects, packing roughly the mass of our Sun into a sphere the size of Earth, with surface temperatures exceeding 100,000 degrees. The formation of this type of supernova requires a specific set of circumstances. The white dwarf must be part of a binary star system, where it can siphon material from its stellar companion. When the white dwarf accumulates too much mass, it reaches a critical point where it can no longer support itself. This triggers a catastrophic chain of runaway nuclear fusion, resulting in an explosion so bright it can be observed across vast distances of space. This process is particularly interesting because it represents the eventual fate of many stars in our galaxy, including our own Sun, though not all will end in such spectacular explosions. The discovery and observation of supernovae like SN2024 help astronomers better understand stellar evolution and the fundamental processes that shape our universe. Next up, 2024 has proven to be a record-breaking year for space launches, with an unprecedented 259 orbital missions successfully placing over 2,700 payloads into orbit and beyond. SpaceX dominated the landscape with an astounding 134 launches, accounting for 85% of all payloads delivered to space, including more than 1,900 Starlink satellites. The United States and China emerged as the primary launch providers, together handling 80% of all orbital traffic. The U.S. led with 54% of launches, while China maintained a strong presence with 26%. Despite launching more missions than in 2023, China matched its previous year's success rate of 65 orbital missions, following an anomaly with their final Lijian 1 rocket launch. Rocket Lab showed impressive growth, achieving 16 successful missions, a 60% increase from their previous year. Meanwhile, Russia's launch activities continued their gradual decline, ending the year with 17 flights. India and Europe each conducted a handful of missions, but are positioning themselves for increased activity in 2025. The final quarter of 2024 was particularly intense, featuring a record-breaking streak of 14 launches within just 7 days during November, and December averaged nearly 1 launch per day, with 30 orbital attempts. SpaceX achieved several significant milestones, including their 400th orbital launch in October and their 400th Falcon 9 flight in November. Looking ahead to 2025, the space industry shows no signs of slowing down. Blue Origin is preparing for the highly anticipated debut of their New Glenn heavy-lift launch vehicle, while SpaceX continues to expand their Starlink constellation and commercial launch services. These developments signal an exciting new chapter in space exploration, with increasing launch cadence and capabilities across the industry. The year's achievements demonstrate not just the growing commercialization of space, but also the incredible reliability and efficiency of modern launch systems, setting new standards for what's possible in space access and orbital operations. While on the subject of successful launches, India's space program has marked another significant milestone with the successful launch of their space docking experiment, known as Spadex. The mission lifted off on December 30th from the Satish Dhawan Space Center aboard a polar satellite launch vehicle carrying two specialized spacecraft designed to test crucial docking technologies. The mission features two 220-kilogram spacecraft, a chaser and a target, placed into precise 475-kilometer circular orbits. These spacecraft are equipped with advanced technology, including a low-impact docking system, laser rangefinders, and sophisticated sensors to enable precise orbital maneuvers. What makes this mission particularly noteworthy is its role in India's broader space ambitions. The technology being tested is essential for India's Gaganyaan program, which aims to make India only the fourth nation capable of independent human spaceflight. The first crewed mission under this program is scheduled for 2026, following uncrewed test flights planned for 2025. But the implications extend beyond human spaceflight. These docking capabilities will be crucial for India's ambitious Chandrayaan-4 lunar mission, targeted for 2027 or 2028. This mission plans to collect samples from the moon's south pole and return them to Earth, a feat that requires precise orbital docking maneuvers to transfer the precious lunar samples from the ascent vehicle to the return spacecraft. The mission's secondary payload module, POEM-4, carried 24 different experiments, including innovative technologies like a walking robotic arm, a debris capture system, and various research modules. This demonstrates India's commitment to maximizing the scientific value of each launch while advancing their technological capabilities. The successful deployment of both spacecraft marks just the beginning of this experimental mission. The actual docking maneuver, scheduled for early January, will be the true test of these new capabilities. If successful, it will represent a major step forward in India's journey toward becoming a complete spacefaring nation. 2024 proved to be a particularly challenging year for NASA, with several dramatic developments testing the agency's resilience and problem-solving capabilities. Perhaps most notably, what began as a routine mission turned into an extended stay aboard the International Space Station for astronauts Suni Williams and Butch Wilmore. Their Boeing Starliner spacecraft encountered issues with helium leaks and thruster problems during its approach to the ISS, leading NASA to make the cautious decision to return the spacecraft empty, leaving the crew stranded until at least February 2025. In an ironic twist, these Boeing test pilots will ultimately return home aboard a SpaceX Dragon spacecraft, extending their intended 3-month mission to 8.5 months. This situation highlighted the ongoing challenges in developing reliable commercial crew transportation systems. On Mars, we witnessed the bittersweet end of an extraordinary mission as the Ingenuity helicopter made its final flight on January 18th. While its crash landing marked the conclusion of its journey, Ingenuity had far exceeded all expectations, completing 71 flights over nearly 3 years when it was originally designed for just a handful of demonstrations over 30 days. This small 1.8-kilogram helicopter proved that powered flight was possible in Mars's extremely thin atmosphere, equivalent to Earth's atmosphere at 80,000 feet. The Europa Clipper mission faced its own dramatic challenges just months before launch. Engineers discovered hundreds of potentially compromised transistors that might not withstand Jupiter's intense radiation belts. After 4 months of round-the-clock testing, they found a workable solution by maintaining the transistors at room temperature, though this required additional power from the spacecraft's massive solar panels. In a final dramatic turn, one of the most intense Gulf of Mexico hurricanes ever recorded threatened the mission's launch. Fortunately, the storm weakened as it crossed Florida, allowing the spacecraft to launch successfully during a backup window. The Europa Clipper is now en route to its 2025 Mars flyby, which will help propel it toward its ultimate destination at Jupiter. All in all, quite a challenging year for NASA. Now, on to an exciting discovery. Located just 105 light-years away in the constellation Coma Berenices, astronomers have discovered a remarkable star system that's been dubbed mathematically perfect. The star HD 110067 hosts 6 exoplanets that orbit in an incredibly synchronized dance, locked together by gravitational forces in a precise cosmic choreography. While this celestial ballet initially suggested a mature, well-established system, new research has dramatically revised our understanding of its age. Previous estimates using traditional stellar aging methods place the system at around 8 billion years old. However, a fresh analysis of the star's activity levels and rotation rate suggests it's actually much younger, only about 2.5 billion years old. The team reached this conclusion by examining telltale signs of stellar youth, including higher levels of ionized calcium in the star's atmosphere and a faster rotation rate compared to older stars like our Sun. HD 110067 completes one rotation in about 20 Earth days, while our more elderly Sun takes at least 27 days, indicating this star is still in its relative youth. This discovery of the system's younger age has important implications for potential habitability. While the 6 known planets orbit too close to their parent star to support life as we know it, there could be additional undiscovered planets in more temperate zones. However, the star's younger age means it's likely still producing intense radiation that could make life challenging on any worlds orbiting within its habitable zone. What makes this system particularly fascinating is how quickly its planets achieved their perfect orbital resonance. Rather than requiring billions of years of gradual settling, researchers now believe this synchronized orbital pattern may have established itself in as little as 1 billion years through gravitational interactions between the planets. As we look ahead to early 2025, skywatchers have an exciting visitor to anticipate. Comet Atlas, officially designated C2024G3, is making its way toward the inner solar system and could provide quite a spectacle, particularly for observers in the southern hemisphere. The comet is scheduled to reach its closest approach to the Sun on January 13th, 2025, coming within a mere 8.3 million miles of our star. To put that in perspective, that's significantly closer than Mercury's closest approach to the Sun. This close encounter means the comet could potentially shine as brightly as Venus in our night sky. However, this extremely close solar approach comes with risks for the comet itself. While analysis of its orbital path suggests it previously visited the inner solar system about 160,000 years ago, there's no guarantee it will survive this encounter. The intense heat from such a close solar pass could potentially cause the comet to break apart. If Atlas does survive its solar encounter, observers in the southern hemisphere will be ideally positioned to view it in the western sky after sunset. The timing isn't perfect, though, as the full moon on January 13th will create some interference. But viewing conditions should improve each subsequent evening as the moon rises later. The comet was first spotted on April 5th, 2024, by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, which gives the comet its name. Like many of its kind, it originates from the Oort cloud, that vast sphere of icy bodies surrounding our solar system. Whether it survives its close encounter with the Sun or not, Comet Atlas promises to provide an interesting start to the astronomical calendar of 2025. And that brings us to the end of today's episode of Astronomy Daily. Thank you for joining me on this journey through the latest developments in space exploration and astronomical discoveries. If you want to stay up to date with all the latest space and astronomy news, head over to astronomydaily.io, where our newsfeed is constantly updating with the freshest stories from across the cosmos. While you're there, you can also catch up on all our previous episodes. Looking to connect with fellow space enthusiasts? You can find us across all major social media platforms. Just search for Astro Daily Pod on Facebook, X, Tumblr, YouTube Music, and TikTok. This is Anna, wishing you a happy new year and signing off until tomorrow's cosmic update. Keep looking up. There's always something amazing happening in our universe.